Speaking of scientists, we have one rock star guest who is joining me today. We have Akash Ashapure, who is a remote sensing scientist at NASA Goddard Space Flight Center. Akash, first of all, I just wanted to thank you so much for taking time out of your very busy schedule to talk with me today. How are you doing today?
Thank you, Jason. I'm doing good. I'm really excited to be part of this podcast. Thank you.
Absolutely, it's my pleasure. And I think, as we can all agree at SSAI, it is a great day at SSAI. Am I correct?
Yes, it is.
Awesome, very good. So, based on your current work that you do at SSAI, it's very inspiring, and I think our audience will very much enjoy our conversation today. So, my first question I wanted to ask you was, can you please tell the audience about yourself and describe the projects you have worked on at SSAI?
Thank you, Jason. I'm Dr. Akash Ashapure, and I work at Science Systems and Applications, Inc., in collaboration with NASA Goddard Space Flight Center, where I am a member of Freshwater Sensing Program in Terrestrial Information Systems Laboratory. My work predominantly focuses on aquatic remote sensing, geospatial analytics, and machine learning, particularly for monitoring and managing water quality from space. At SSAI, I have been involved in several cutting-edge projects where our major focus is on aquatic remote sensing and machine learning. The core of our work is developing data-driven models to enhance atmospheric correction for optical satellites. Now, for those unfamiliar with the term, atmospheric correction is the process of removing distortions caused by atmospheric particles, gases, and aerosols so that the satellite data accurately represents what is happening on the Earth's surface. This is a very critical step in remote sensing because without it, the data can be misleading. So a major component of our research is to develop biogeochemical parameters also down the line, such as chlorophyll A, total suspended solids or TSS, or also colored dissolved organic matters, or also known as ACDOM. These biogeochemical parameters help us understand the health of both fresh and coastal water ecosystems. These parameters are also like health indicators of water bodies, helping us detect sediment transport and harmful algal blooms that can affect drinking water, fisheries, and overall biodiversity. For the data, we predominantly rely on multi and hyperspectral optical satellites, which allow us to observe water bodies in unprecedented details. Some of the major satellites that we focus on include NASA's Landsat series, which is one of the longest running Earth observation program, providing valuable data. Historically, our team has been part of the Landsat science team for aquatic applications. Another satellite that we focus on is EMIT, which is Earth Surface Mineral Dust Source Investigation. Its hyperspectral imaging capabilities are also useful for water quality monitoring. Our team is part of the EMIT science team, which I represent as a principal investigator. Another satellite that we consider is PACE, which is Plankton, Aerosol, Cloud, and Ocean Ecosystems. It is a recently launched mission that is transforming ocean color remote sensing by providing unprecedented hyperspectral data to monitor plankton dynamics, aerosols, and cloud interactions with marine ecosystems. Our team is also part of the PACE Science team, which one of my colleagues is serving as a principal investigator. Other satellites that we also utilize includes commercial satellites like Planet SuperDove. It is also a especially high resolution imagery that we can use to refine and enhance water quality assessments. The excited part of our work is that we don't just process and analyze data. We make sure that it's usable for decision makers. We do this through our online platform called The Stream, which is a satellite-based analysis tool for rapid evaluation of aquatic environments. It integrates data from NASA and ESA satellites to provide near real-time water quality products. This platform is designed to help scientists and policymakers to make better informed decisions regarding fresh and coastal water management. In a way, Stream's impact goes beyond remote sensing advancements. It puts cutting edge science directly in the hands of water resource managers, a crucial step towards protecting and managing our vital water systems. This exemplifies how scientific research can deliver immediate real world benefits to the society. For our work, we are also collaborating with government agencies, commercial satellite providers, university professors, students, and also international partners to apply these technologies to real-world monitoring challenges. One of the most rewarding aspects of my work is mentoring students and young researchers and helping them apply remote sensing techniques to solve pressing issues. Additionally, we also are heading towards automating the water quality retrieving using cloud-based platforms, which is going to allow researchers worldwide to access high-quality, satellite-driven water quality products without requiring specialized computing resources. This makes remote sensing more accessible and ensures that the small research institutions, government agencies, and various groups can leverage these kind of satellite data very efficiently. We are also conducting comparative studies on water quality trends over decades, allowing us to analyze long-term challenges in aquatic ecosystems due to urbanization, due to industrialization. This historical perspective is very crucial because it helps in identifying various trends, different anomalies, and appropriately consider urgent areas for intervention. By combining past and present data, we are developing models to predict future water quality conditions, which gives decision makers a much valuable insight on how water resources may evolve over the year.
Wow, Akash, that is absolutely incredible in terms of the projects that you and your team are involved with. And I love hearing that you are working with a multitude of different types of people as well, which really broadens the impact there. So I really appreciate you sharing all that. And I appreciate you highlighting as well about atmospheric correction. That is something I didn't know. So I really appreciate you breaking that down and defining that. So again, it's absolutely incredible. And Akash, I wanted to transition on to my next question that I wanted to ask you, which is how is remote sensing transforming our understanding of water quality and aquatic ecosystems? And what are some of the most exciting advancements you've seen in this field while being at SSAI?
Thank you, Jason. Remote sensing is revolutionizing how we observe, monitor, and protect our water bodies by giving us a global perspective on aquatic ecosystems in a way that was impossible with traditional field measurements. In the past, researchers had to rely on localized field sampling, which is expensive, time-consuming, labor-intensive, and most importantly, limited in coverage. Today, satellites allow us to continuously monitor a very large water bodies, vast water bodies across the planet with a level of details that was unthinkable just a few decades ago. Now, some of the biggest transformations in water quality monitoring that I have observed is the availability of high resolution satellite imagery or hyperspectral sensing. What does it mean is traditionally remote sensing satellites capture broad spectral bands, but new generation satellites like PACE, EMIT, which we talked about earlier, and Prisma, these satellites provide hyperspectral data, which allow us to see an extremely detailed spectral fingerprint of different water quality components that was not possible before. This has also allowed us to detect harmful algal blooms and track sediment transport after extreme weather events. Another transformation is AI and machine learning of water quality predictions. At SSAI, we use machine learning models trained on historical and real-time satellite data to predict water quality fluctuations. For example, our models can forecast where harmful algal blooms might appear before they even form. So, in a way, giving communities time to prepare and respond. AI-based models also help us automate the process of removing atmospheric distortions. AI has enabled us to utilize simulated data. We don't even have to use real data for training. So it reduces the time for extensive field measurements during the model development. By generating millions of simulated samples, we can train our models more efficiently and apply them to real-world data for atmospheric correction. The results demonstrate significantly improved accuracies compared to traditional AC processing mechanisms available, making this approach a game changer in the remote sensing. Another big transformation that I have observed is bridging the gap between space and the local water management, meaning NASA's remote sensing data is now being integrated into local, national, and international water policies to support better water management. Governments and researchers are using satellite-based insights to track industrial discharge. New collaborations between the public and private sectors are enabling satellite technologies to be applied directly in agriculture, fisheries, and also in urban planning. We are also working on making remote sensing data user-friendly for water managers by developing intuitive dashboards and by making easy to interpret visualizations to support them. Overall, I would say remote sensing is no longer just an observational tool. It is an active player in shaping global strategies.
Wow, that's truly fascinating and very interesting to hear, Akash, in terms of how specifically remote sensing is transforming our understanding of water quality and aquatic ecosystems. And I really appreciate you highlighting what SSAI is doing in terms of contributing to that. I think as we can all agree with all of the technology advancements that we've had over the last several years, we're definitely finding new ways of, organizing our data and trying to use those data points to make even more discoveries as well, which is great. So in terms of what you and your team are contributing to right now, it's very fascinating and very engaging as well to hear. So I really appreciate you highlighting more just about that. And transitioning, Akash, onto my next question that I had for you. My question is, with water resources that are being impacted globally, how can satellite data and remote sensing technologies help us monitor and protect freshwater and marine environments more effectively? How has SSAI done that?
Satellite technology provides a powerful toolset to safeguard both fresh and marine ecosystems. How remote sensing is helping protect our water resources by detecting water contamination. How it does that is satellites can track oil spills, industrial water waste, and agricultural runoffs and harmful algal blooms in real time. By using multi and hyperspectral sensors, we can also identify the sources and monitor their spread. And by detecting drought and water support monitoring also, satellites like Landsat and Sentinel-2 and also MODIS, we can monitor river flows, reservoir levels, and groundwater depletion. Countries and local governments can use this information to manage drought conditions and water supply more efficiently. Satellite helps us study ocean acidification, coral bleaching, and shifts in marine biodiversity. Also, early warning systems for floods and coastal erosions, satellites can be very useful. Satellite-based flood mapping helps emergency response team predict and manage flooding events. And also, coastal communities use these satellite data to monitor shoreline erosion and depletion mitigation plans can be made based on that. By combining remote sensing, machine learning, and real-time monitoring, we can proactively protect our water ecosystems.
Wow, those are excellent points that you brought up, Akash, in terms of what satellites can do. And I really appreciate you exploring and explaining a little bit more about that. And my last question, Akash, I wanted to ask you was, and this is a fun question, just as a side note, but the question is, if you could take a remote sensing road trip across Earth's waters, whether it be, rivers, lakes, and even oceans, what would be the top three places you want to analyze from space, and what secrets do you think they might reveal?
Thank you so much. That's a fantastic question. I mean, if I could embark on a remote sensing road trip across Earth's waters, my top three destination would definitely include number one would be the Amazon River and floodplains in South America. Because the Amazon basin plays a crucial role in the global carbon and water cycle. Using hyperspectral and even multispectral sensors, we could track river dynamics. The second place I would want to go would be the Great Barrier Reefs in Australia, because this is the largest coral reef system on planet Earth. So with remote sensing, we can track coral bleaching in real time, analyzing water temperature trends and assess the impact of ocean acidification on marine biodiversity. The third place, let me think. The third place I can think of is the Arctic and Antarctic ice sheets. The polar regions hold massive freshwater reserves. Remote sensing can definitely help monitor ice loss. It can also help us track glacier retreat and study phytoplankton blooms under shifting ice conditions. So each of these locations that I mentioned holds very critical insights into water availability and ecosystem resilience. Satellites allow us to see the invisible patterns shaping our planet's future that we cannot see with the naked eyes.
Wow, those are excellent road trip places that you would like to go to, Akash. That'd be very cool to see them all. But that is just awesome, Akash, and I really appreciate you sharing more about that. And with that, Akash, as I said, thank you again so much for taking time out of your very busy schedule to talk with me today and do this podcast episode recording. You are truly a rock star and making a phenomenal difference here at SSAI. And everybody around the world is going to continue to be fascinated by the great work that you and your team are currently doing right now. Please definitely keep us informed about some continued insights and some continued data that you get in relation to you and your team's research, and we cannot wait to highlight it.
Thank you so much, Jason. I really appreciate the opportunity to discuss my work on this podcast, and I'm excited to be part of this journey. We are right now at the frontier of using satellite data, machine learning, and cloud computing to make monitoring more accessible and efficient. As we continue to refine these methods, we hope to see even more disaster response and ecosystem restoration. With that, I would like to stop here. Thank you so much for having me. It's been an honor to share my work with you. Thank you so much.